Hey you guys, today we're going to be continuing with our characteristics of functions. So yesterday we looked at how to find the domain and the range of a function. Today we're going to look at the x and y intercepts of a function. So the x-intercept of a function is where the graph of the function crosses or touches the x-axis. Alright, so either of those give us an x-intercept. The y-intercept is where the graph of the function crosses or touches the y-axis. So if we look at our graph over here, the x-axis runs horizontally. So we have 1, 2, 3 x-intercepts. So where the graph crosses the x-axis, that gives us our 3 x-intercepts. If we look at the y-axis, the graph crosses one time. And we'll always only have one y-intercept. And we'll talk about why that is later this week. But it crosses one time, so because of that, that's our y-intercept. Alright, so we're going to look at a few examples and go through and find the x and y-intercepts for each of them. So first we've got the graph of this function, and we want to find the x-intercept. So to find the x-intercept, we're looking for where the graph crosses or touches the x-axis. So looking at this graph, there's only one spot where the graph touches the x-axis, and that's right here. And when we write the x-intercept, we always write it as an ordered pair. So we always write it with an x value and a y value. So we're looking for this point. So first we need the x value. So that's how far it is from 0 horizontally. So that's 1, 2, 3 to the left. So our x value is -3. And then our y value for our x-intercept is how far up or down it is. Since we stayed on the x-axis, we didn't move up or down any, the y value for the x-intercept is 0. And that is always going to be the y value for an x-intercept. No matter what, the x-intercept has a y value of 0. Next, let's look at the y-intercept. So, for our y-intercept, we want to see where it crosses the y-axis. So that looks like it's happening right here. And we don't know exactly what that number is based on the graph, so we're just going to give it our best guess. We're going to try and get as close as we can as a decimal. As long as you're relatively close, I would give you credit for this. So looking at our graph, first we need the x-coordinate. So the x-coordinate, we didn't move left or right any, so the x-coordinate is 0. And the y-intercept, the x-coordinate is always 0 because on the y-axis, x always equals 0. Then we need the y-coordinate, so we want to know how far up this is. So this is 1 right here. This is 2 just above it. So it's a little bit closer to 2 than it is to 1. So because of that, I'm going to say that that's probably about 1.8. And that it's not exact. If we had the equation for the function, we might be able to find it algebraically, or if we had this on a calculator, we could find the x-intercept. But just looking at it based on the picture we have, we're just going to give it our best estimation. So I'm going to say 0, 1.8. You might think it's 1.9 or 1.7, but as long as you're kind of in that general area, you're good. All right, so that's the x and y intercept for this graph. Let's look at the next one. Alright, so again, we want to try and find the x-intercepts and then the y-intercepts. You could do the y-intercepts first. I just do x first because it's first in the alphabet. So for the x-intercepts, we're looking for where our graph of our function crosses the x-axis. So if we look along the x-axis, our graph crosses right here, and our graph crosses right here. So we need to know what the x values are for those points. So for the first one, this is 1, 2, 3, 4, 5 to the left. And I know it's kind of hard to see on the screen here. If you look at your notes, it might be a little easier for you to count it over. But we said it was 5 over to the left from the origin. So that x-coordinate is going to be -5. And then the y-coordinate for an x-intercept is always 0. So -5, 0. But we have more than one x-intercept for this function, which is totally fine. So we need to figure out the x-coordinate of this intercept. So this is the origin. That point is 1 from the origin to the right. So that point is going to be at positive 1, 0. And that is our x-intercept. All right. Now for our y-intercept, we're looking at the y-axis at where the function touches or crosses this axis. So that's happening right here. And so we know the x-coordinate is going to be 0 because the x-coordinate is always 0 for the y-intercept. Now we just need to know how far up or down this is. So this is the origin. We move down 1 to get to that y-intercept. So the coordinate there is going to be 0, negative 1. So that is the x and the y-intercept for the graph of this function. All right, we're going to talk about how to find these algebraically. So there are steps you can take to find it based on the equation of a function rather than based on the graph. Sometimes you're not going to know at first how to solve these algebraically, so as we go throughout the year, as we get to each different function, we'll talk specifically for that function on how to solve for these x and y intercepts. But to start off with, I tried to give you some that you could follow along with. But to begin with our rule, to find the x-intercept algebraically, we're going to replace y with 0. And then we're going to solve for x. And the reason why we do that is because, like I said earlier, at the x-intercept, the y-coordinate is always 0. So when we have an equation, we can replace y with 0. Then to find the y-intercept, we're going to replace x with 0 and then solve for y. So we do the opposite. For the x-intercept, we replace y with 0. For the y-intercept, we replace x with 0. So let's look at a couple of examples of how to do that. So we need to find the x-intercept and the y-intercept for each of these. So I'm going to start with the first function, y equals 3x plus 11. And I want to find the x-intercept to start off with. And I'm going to label what I'm doing. That way it's a little bit clearer. So to find the x-intercept here, I need to replace y with 0. So I get 0 equals 3x plus 11. Then I need to solve for x. And when I'm solving an equation, I work the order of operations backwards. So I start with adding and subtracting. So here I have a plus 11. I need to get x by itself. So I need to get rid of that plus 11 by subtracting 11. 11 minus 11 is 0, so those would cancel out. 0 minus 11 is negative 11, and then we can bring down the 3x. After adding and subtracting, moving up in the order of operations, we get to multiplying and dividing. So we have 3 times x. We need to get rid of the 3 to have x by itself. So we'll divide both sides by 3. 3 divided by 3 would be 1. So those would cancel and leave us with just 1x, which we could write as just x. Then over here we have a negative 11 over 3. And we're just going to leave it as a fraction. We could try and get a decimal. If you like decimals, you can feel free to do that. But I like to just leave it as a fraction because it's one less step. So that's the x-coordinate of our x-intercept. But we said earlier, an x-intercept is a point on the graph. And a point is written as an ordered pair. So we need to write this as an ordered pair. So coming back up here, the x-intercept for this function is going to be negative 11 over 3, 0. So we plug in whatever our x value was, and then 0 is the y value for the x-intercept. All right, then I might have to give myself more space. Okay, for the y-intercept, we're going to replace x with 0 and solve for y. So we have y equals 3, replacing x with 0, times 0 plus 11. To solve for y, now all we have to do is simplify. 3 times 0 is 0. Then we bring down our plus 11. 0 plus 11 is 11. So that gives us our y value. So when we write our y-intercept, our x value was 0, so that's the first number. And we said y was equal to 11. So 0, 11 would be our y-intercept for that function. All right, next we have y equals x squared minus 4. So first we're going to start with the x-intercept. To find the x-intercept, for this function, I replace y with 0 and solve for x. So 0 equals x squared minus 4. Then we work the order of operations backwards. So first is addition and subtraction. We got to get rid of all of that. So to get rid of the minus 4, we're going to add 4. 0 plus 4 is 4. Bring down the x squared. Negative 4 plus 4 is 0, so that goes away. So next, after adding and subtracting, we get to multiplying and dividing. Well, there's nothing being multiplied or divided by x, so we don't have to do that step. Next, in the order of operations going backwards, we get to exponents. So we want to get rid of the exponent. Right now we have a power of 2 on that x. So to get rid of an exponent, you do the opposite, which is taking the root. So if it's x squared, we're going to take the square root. And we'll do a little bit more of that when we get to our section on x squared. But this is just an example here. So to get rid of the squared on x squared, we take the square root of both sides. So when we take the square root of x squared, that gets rid of the power of 2 and leaves us with just an x. And when we take the square root of 4, we get 2. And here's the thing that's going to be a little bit different than what you've probably done before. In Algebra 2, if we're talking about functions, if we take the square root of a number, we want the positive number and the negative number. So the square root of 4 is 2 because 2 times 2 is 4. But we're also going to say that the square root of 4 is negative 2 because negative 2 times negative 2 equals 4. So to show us that, we're going to write plus or minus 2 right here. And when we come over to the side to write the x-intercept, we're going to write first 2, 0 for the positive 2. But we also have another x-intercept, and that's going to be negative 2, 0. So those would be our two x-intercepts for this function. All right. Now let's look at the y-intercept. So for the y-intercept, we're going to replace x with 0 and solve for y. So here we would have y equals 0 squared minus 4. When we simplify that, 0 squared, or 0 times 0, gives us 0 minus 4. So we get y equals negative 4. So for our y-intercept, when we write that as a point, we have 0, negative 4. So that would be our y-intercept for that second function. So I'm going back and boxing in the ones that I didn't box in earlier. All right, and then finally, hopefully, I have enough room for this. We have the function y equals negative 5x plus 15. So again, we're going to start with finding the x-intercept. So to find the x-intercept, we replace y with 0. So we have 0 equals negative 5x plus 15. We want to get x by itself. We're trying to isolate that variable. So to get rid of the plus 15, we're going to do minus 15 on both sides of the equal sign. So 0 minus 15 is negative 15. Bring down the minus 5x, and then 15 minus 15 is 0, so we don't have to write that part down. Next, we need to get rid of the multiplication. So we have negative 5 times x. To get rid of that, we need to divide both sides by negative 5. When we do that, negative 15 divided by negative 5 is positive 3. Negative 5 divided by negative 5 is 1. So those would cancel out, leaving us with just x. So when we write the x-intercept, our x value is 3, our y value is 0. So that would be our x-intercept, 3, 0. And then for our y-intercept, we're going to replace x with 0. So we're going to come back up to this function. We have y equals negative 5 times 0 plus 15. I kind of ran out of space there. Negative 5 times 0 plus 15. Then we can go through and simplify. So we get y equals negative 5 times 0 is 0 plus 15. 0 plus 15 gives us y equals 15. So when we write that as our y-intercept, x value is 0, the y value is 15. So 0, 15 is our y-intercept. I know I kind of got all over the board doing the math here, But those are going to be your x and y intercepts. Now, as you're doing this, I forgot to mention this earlier, I'm so sorry, but as you're trying to take your notes, you may want to show the work on paper and then take a picture of your work and paste it into your notes. That way you're not having to try and type all this out, because that would get really confusing really quickly. All right, let me know if you guys have any questions about x and y intercepts, and have a great day.